Imagine falling asleep. Then suddenly you wake up and remember you have a math test about division of radicals tomorrow.
Oh shit. How am I gonna study? Oh, they're getting the traffic.
Oh sir, you've approached the right person, or you've waken up to see the right person. I'm currently making a video about the division of radicals. Division of radicals. Radicals are numbers or expressions written with a root symbol. In mathematics, operations on radicals are guided by specific rules to ensure expressions remain simplified. One of these operations is division of radicals, which involves dividing two radical expressions with the same or different terms. What are division of radicals? Well, the division of radicals is the process of dividing one radical expression by another, such as this example. For radicals with the same index, we combine them into a single radical. The property is called the quotient rule of radicals. We're in the Amazon forest right now, trying to search for someone to ask about division of radicals. I see a wild orangutan. Let's go approach him. Excuse me? Do you know the division of radicals?
Is dividing one radical expression to another.
Correct. Excuse me, sir? Do you know the division of radicals?
Fuck no.
Why not?
I don't know, I just got here, bro.
Where were you?
There?
Where there?
Over there, over by the tree.
Our example number 1 is basic division. What is basic division? It's division. Simple. For number 1, we have the square root of 18 over the square root of 2. And it's equal to the square root of 18 over the square root of 2 again. Then we have the square root of 9. Then we have 3. 3 is our final answer because that's what my phone says. Then we have larger numbers. Larger numbers are basically basic division except with numbers that have a higher value. We have, for example, the square root of 50 over the square root of 2. It's equal to the square root of both 50 over 2. Then we have the square root of 25, which is equal to 5. Then we have your final answer, which is 5. We are currently filming in the midst of another hurricane. As you can see, my clothes are wet. But what's stronger than the force of a hurricane? The force of the division of radicals! Of division of radicals, there must be the same index. What is an index, you may ask? Well, an index is a number that indicates the root being taken. It's the small number written outside the radical sign. For square root, the index is always number 2 because it's called square root. Then for the cube root, the index is number 3, which is written outside the radical sign. Then for the fourth root, the index is 4. Self-explanatory, I said 4. The index tells you which power to raise the result to get the original value. That's the first condition for division of radicals. Then for the second condition of division of radicals, we have the non-zero denominator. Ooh. For the non-zero denominator, actually, let's ask ourselves first. What is a non-zero denominator? A non-zero denominator is a value that is not equal to zero, used as the bottom part of a fraction. In other words, it's a denominator that has a value, making the fraction valid because it's not zero. Zero has no value, and any other number except zero has a value. Let's say one. One has a value, and what is the value of one? It's one. It's simple. Then why is why is it important? Like why is it important? In fractions, division by zero is undefined, meaning it's garbage. So a non-zero denominator ensures the fraction is mathematically valid, such as the denominator being any other number other than zero. For the third condition of division, ooh, see that rhymes because I'm smart like that. Math smart, English smart, rap smart. No, I'm the next Eminem, by the way. For the third condition, we have simplify inside first. Self-explanatory. We have to simplify the inside part of the equation. After combining radicals, simplify the expression under the radical sign as much as possible. Because if we don't simplify, it might be the wrong answer. And if you have the wrong answer, you're not graduating. You won't get a job. As I said, you gotta simplify it. Because if you don't, just don't go to school anymore. For number 4 of division of radicals as our condition, the final answer must be in simplest radical form. So, if you follow all the steps, all the conditions, 1 to 3, you end up in number 4. Because if you count 1, 2, 3, 4, it's the next number. If you follow all of those, you'll probably getting the simplest radical form, which is most likely the answer. For step number 6 or number 6, we have the special case, which is rationalizing the denominator. If the denominator does not contain a radical, if it does contain a radical, we rewrite the expression so that no radical remains in the denominator. Rationalizing the denominator means removing any radicals from the bottom of a fraction. This is done to simplify expressions and make them easier to work with. How do you rationalize? Well, number 1, identify the radical. We find the radical in the denominator. Then we multiply by a clever form of 1, which is multiply both numerator and denominator by the radical or its conjugate. In math, there's something called a conjugate. A conjugate is a pair of expressions that have the same terms but opposite signs between them. For example, the square root of a plus b and the square root of a minus b. Those are conjugates. The number 3, we simplify. Simplify the expression. Then you get your answer. This is the finale and the conclusion of division of radicals. The division of radicals relies on the quotient rule and simplification techniques. As long as radicals have the same index and the denominator is non-zero, they can be combined into a single radical for easy calculation. And we have the mastery of these rules is essential in algebra and advanced mathematical problem solving. If you do not learn the division of radicals, you will fail. Fail where? Fail in life. You won't get a job, you won't find a family, you won't find someone who loves you. You will fail everything in your life, you won't be successful, you will die.
Please, Pete, I need this. My mom is kind of homeless.